Happy Friday. We are in lesson 4.6, which is the quadratic formula and something called the discriminant. Right now, students are working on the warm-up problems. I'm going to start doing number 1 here. If you're still working, that's fine. If I want to solve quadratic equation by factoring, my first step would be to set this equal to 0. It's not asking me to complete the square. It's asking me to factor. So I'm going to move over the 8x by subtracting it over, and I'm going to move over the negative 5 by adding it, so I'd get a positive 3. All right, with factoring, our first step is there a GCF we can factor out right away? In this case, there wasn't. How many terms do I have left? 3 with a 5 in front, so I'm going to do AC method. 5 times 3 is 15, so you got to find two numbers that multiply to 15 and add to negative 8. Okay, did anybody get those two numbers?
Negative 3 and negative 5.
Negative 3, negative 5. Good job. Thank you, Wesley. All right. With the AC method, once we get there, we break up this term into negative 3x and negative 5x, and then we factor by grouping. It's been a while. This is review. Refresher. So I'll split it in half. Factor by grouping. First group, all I could factor out is an x. I'd be left with 5x minus 3. In my second group, I would need to factor out a negative 1 to be left with 5x minus 3. So that factors into 5x minus 3 times x minus 1. This is an equation. I see an equal sign, so I got to use ZPP to actually solve. So set these each equal to 0. Oops. And we get solution of 3/5 and 1. That's just one of the ways we could arrive at those two solutions, but the directions did say that we had to solve by factoring. Question?
So, does it matter what way you put 20, 30,
Nope. Nope. Doesn't matter. Should still factor the same. Okay. I don't mean to go too fast, but that's review, so. Okay, simplifying radicals. I noticed we struggled with these on the quiz. And these are technically reviewed from like Algebra 1 and this geometry. So, this, first I check if I can like simplify the fractions. All right, so 35 over 12, I can't simplify that. But if I see something like this, the square root of 14 over the square root of 2, that quotient like property says we can combine them under one radical and divide them. So that's the same as the square root of 7. That's what I did first. Okay. Then I actually multiplied them together. So you can think of this as 7 over 1 in there. So we get 7 times 35, which is 245, over 1 times 12, which is 12. Now I have to like simplify this because I can't have fractions under a radical. So I square at the top, square at the bottom. And then I simplify both of these. Unfortunately, neither of those are perfect squares. 245 does have a perfect square factor. Did anybody find it? Just curious. Anyone get this far? Find what perfect square goes into 245? It's kind of a big one. 49. It's 49 times 5. So that top would be 7 root 5. 12's easier. That's obviously 4. 4 and 3. So that simplifies to 2 root 3. Okay, that's what I do first. Some of you just like left the square root of 27. I'm like, whoa, 27 has perfect square factor, right? That was the one on the quiz, I think. All right, now I have to rationalize. So I have a radical my denominator. This one's a doozy. Lots going on here. So times the top and bottom by the square root of 3. To get rid of that radical in the denominator. So up top I have 7 times root 5 times root 3 would be 7 root 15. On bottom, 2 times root 3 times root 3, so that ends up being 2 root 9, or the square root of 3 times the square root of 3 is 3, so 2 times 3, 6. Would be your final answer there. 7 root 15 over 6. There's different ways you can go about that too. It doesn't have to be like this step-by-step that I did. But that's just the process I do every time. First, I like multiply or divide them. I get them all together. Simplify if I can. Square at the top, square at the bottom, simplify again, and then worry about if there's any radicals in the denominator. I do that step last. Is because sometimes once you simplify things, like it might end up being a perfect square, or it might kind of undo the fraction. Like that 14/2. If you started like trying to rationalize this right away, look what happened. Once I simplified the fraction, I just ended up getting the square root of 7, right? So sometimes they kind of like work themselves out of the denominator. All right, so keep practicing those ones. They obviously come up a lot with quadratic formula too, simplifying radicals, so we'll get more practice with that. All right, so that's just general couple review problems I picked because we're in 4.6 already. I showed you where the quadratic came from. I played the song for you that you guys loved, and we just did one example together. So let's pick it up right here with number 2. So just as a reminder, this works for any quadratic equation, even if it's not factorable. And this is basically what I do if the equation doesn't factor. Sometimes I might complete the square, but if I get like nasty fractions, I usually don't complete the square, but you can do it with nasty fractions. There's one on the quiz with a kind of nasty fraction that you had to do. So it works, but quadratic formula to me is just a little bit quicker. Remember, you do have to set it equal to 0 first though. So my first step here, number 2, would be to set it equal to 0. So that'd be a -2. And then you identify your A is your number in front of x squared. B is your number in front of the x term or the middle term. C is your constant. And then you just plug and chug. All right, so you have the formula written down in your notes right here. One thing I do want you to do, we're going to get to this in a little bit. Highlight, if you have a highlighter or maybe like a different color pen or something, highlight this piece under the radical. That b squared minus 4ac. We're going to come back to that and I'll explain what it is, but it's a little special expression that tells us a lot about our types of solutions we're going to get. Okay, so highlight that to be continued. So my quadratic formula, if I'm looking up there, x equals the opposite of b. So in this case, the opposite of b would be positive 10, since b is negative 10, plus or minus the square root of b squared. And make sure you put that in parentheses, especially when b is a negative. B squared minus 4 times a times c. A is 1, c is -2, all over 2a. Okay, so how I tackle these problems always is I do this piece in my calculator. So you're going to literally type it in like this, -10 squared minus 4 times 1 times -2. Do not do the radical. Don't do the square root. Just figure out what that piece is. That's the piece I highlighted. I got 108. So we get here. And then on the bottom, we can do 2 times 1 is 2. Now, yesterday, the one we did, we ended up getting a perfect square. We got the square root of 256. Is 108 a perfect square? Unfortunately not. Okay, if you square root that in your calculator, you're going to get a decimal. So what we have to do is simplify this radical. So we have to look for perfect squares that go into 108. There's a bigger one. 36. Yep, it's 36 times 3. Remember, we always want to look for the biggest one. So that simplifies as 10 plus or minus 6 root 3 all over 2. All right, now since we have 3 terms in this fraction, 10's a term, 6 root 3 is a term, and 2's a term, you can simplify this as long as they all have a common factor. All right, so 10, 6, and 2 have a common factor of 2, right? So we can do 10 over 2 would reduce to 5 over 1, so 5. 6 over 2 would reduce to 3. However, if the problem was like this, you don't have to write this down. We couldn't divide everything by 2. I mean, you could write it like this if you wanted to. You could like split it up like that. But you can't do, there's nothing here that's divisible by 2. So you can't technically like divide out a 2 from everything unless they all have a 2 in common. Okay, so that'd be my final simplified answer. The only times we want decimals is when we're doing word problems, which those are at the end of our notes. So always err on the side of leaving your answer in simplest radical form, just like we did with completing a square. Okay. We're going to look at 2 more examples when something different happens here. And then we'll come back and talk about that highlighted part and how it's special and how it helps us determine what kind of solutions we're going to get. Okay. Big numbers here. The directions tell me I have to use the quadratic formula, but in real life, if I were to solve this, I'd set it equal to 0. And I'm looking and I was like, these are some pretty big numbers. I don't think I want to try and factor this. Quadratic formula. Go ahead, plug and chug. A is 25. B is negative 20. C is 4. Okay, you guys want me to sing this song? X equals negative B. What's the opposite of B here? Positive 20. Yep, positive 20. Plus or minus the square root of B squared minus 4AC. All over 2A. All right, so negative 20 squared minus 4. A is 25. C is 4. All over 2A. Okay, again, folks, just type this piece in, not the radical, just that piece underneath. It's called the discriminant. That's what that's called. Somebody tell me what you get for a number there.
400 for both of them.
What'd you get?
Yeah, 400 for both of them, so yeah, 0.
Oh yeah, 400 minus 400. 0. We end up getting 0. Uh-oh. That's okay. You have plus or minus nothing, so essentially like this part just kind of like drops out. So we're just left with 20 over 50, which is 2/5. We just get one answer. And remember, that can happen when we're solving quadratics. We can get just one answer. We'll talk about what that means in a second. Okay, so don't forget if that happens. That can happen. Here's the other thing. This one you would have not have seen before this class because now we're going to get some imaginary numbers, okay? And now this can happen now that we know how to work with imaginary numbers. So let's set it equal to 0. Do you see how my 7x squared is negative? So I'd probably move it to the other side. I always like to try and keep a positive. I don't know why. To me, it's just easier, and that's a good habit to get in, especially when you're factoring too. So I'd probably move everything to this side, make that a 7x squared. That would become a negative 2x and a positive 4. You don't have to. It'll work out either way. A is 7. B is negative 2. C is 4. All right. Plug and chug. I'll lose it on this board. Sometimes I like to do this, just like a little template. All right, the opposite of B would be a positive 2. B squared minus 4A C. And I just plug in my numbers. All right. Somebody with a calculator, please crunch that number for me.
Negative.
What'd you say?
Negative 100.
Negative 108 is also what I got. So we get this. 2 plus or minus the square root of negative 108 all over 14. We just simplified the square root of 108 in the last one. It was 36 times 3. But now that it's negative, what else am I going to have? I. Yep, square root of negative 1. I'm going to have an I. All right. So that would get me 3 root 3 I all over 14. Now with imaginary numbers, we like to write them in standard form, so we are going to break this up. A little harder on it if you want. My real part would be this 2 over 14, which that would reduce to 1/7. Plus or minus my imaginary part. Oh, this should be a 6. Sorry. This should be a 6. Square root of 36 is 6. 6. Ooh, I think I caught that. My imaginary part would be 6 root 3I over 14, which 6/14, that would reduce to 3/7. So we'd write this as 3 root 3 over 7I. Okay, that's that standard form. Real part first, imaginary part second.
Is it okay if we write the I in the numerator though?
Yes, that's fine if you're at the I in the numerator. Yep. Okay, so we basically just did an example of like every type of situation you could have. You could have something that's a perfect square, and you get 2 whole numbers underneath the radical. You could get something that's not a perfect square, but we can simplify it. You could get something where you have a 0 under the radical, and you just get 1 solution. Or we have a negative number on a radical, and we get imaginary solutions. That's really like the 4 possible things that can happen. All right, so that's basically what that little discriminant, that b squared minus 4ac, what that tells us about our solutions. So I told you to highlight this. Now I want you to go back, and I want you to write that this is called the discriminant. And if I just crunch that little piece under the radical, the b squared minus 4ac, if I just crunch that number, I can figure out what types of solutions I'm going to have. If I get a perfect square for the discriminant, I'm going to get 2 real rational, meaning no radicals, 2 real rational solutions. They don't have to be whole numbers. They just ended up being whole numbers in this case. If I get something that's positive but not a perfect square, I'm going to have 2 real irrational solutions. All right, so that's what this first box says. If we get a discriminant that's positive, greater than 0, that's just saying positive, and it's a perfect square, we're going to get 2 real rational roots. And what that looks like on a graph means 2 rational x-intercepts. Now, if my discriminant is still positive, but it's not a perfect square like that one that was 108, we know we're still going to get 2 real solutions, but these are irrational numbers because now I have radicals. So on a graph, they would still cross, but I wouldn't be able to tell exactly because they're irrational. All right, does that make sense? So that's basically saying like, hey, if you get a positive number as a discriminant, you're going to have 2 real solutions. If it's a perfect square, they're going to be rational, they're going to be fractions or whole numbers. If they're irrational, they're not going to be exact. Okay, what about that one where our discriminant was 0? How many solutions do we end up getting? Just 1. Just 1. What does that look like on a graph? Well, our only x-intercept, our vertex, must be sitting on the graph somewhere. It could look like that. It could look like this. But if my discriminant is 0, I'm only going to get 1, still real, and it's going to be rational because the radical part drops out. 1 real rational root. Meaning if you were to graph it, your vertex would be that solution because that's the only way it can cross the x-axis 1 time. You look like you're confused, Carter.
No.
Do you have a question? Okay. And then the 4th case scenario is if our discriminant ends up being less than 0, or another way to think of that is our discriminant ends up being negative. What type of solutions do we have?
No.
Imaginary solutions, but no x-intercepts, right, because they're imaginary. So we have 2, you could call it complex or imaginary solutions. Okay. So we're gonna just do one of these examples, and there's a few of these like on your homework in the textbook, where I call these floaters too. When I graph these, I'm like, ooh, they're floaters. So if I were to graph them, before you guys just said, if you graph ones like this, remember you said no real solution? Technically they have a solution, they're just not real. They're imaginary. It's weird, right? I call them floaters. They could be like happy faces up there, sad faces down here, but they don't cross the x-axis. We can still solve the equations, they're just not real solutions, meaning they don't actually have x-intercepts. Okay, so here's a breakdown of like a problem like this. Complete parts A through C for each quadratic equation. We're just going to do one of these. So A says find the value of the discriminant. So the discriminant is just that piece that's under the radical, the b squared minus 4ac. Describe the number and types of roots, and then go ahead and find the exact solutions by using the quadratic formula. Okay, so let's start with letter A here. So I just want to calculate the discriminant. I'm not doing the whole formula. I'm just doing b squared minus 4ac. Looks like my equation is set equal to 0 for me. Nice. So I can easily identify my A, my B, and my C. Okay, so let's go ahead. Don't forget to use parentheses when you're squaring B. So b squared negative 3 squared minus 4 times 3 times 8. What do we get? Negative 87. Negative 87 is what I got. Okay, that's the discriminant. So what that tells me, and you can do this over here because in letter C, we're going to solve it in a second. What that tells me is when I do my quadratic formula, I'm going to get negative 87 underneath that radical, right? That's the piece that we're looking at, the discriminant. So to answer B, describe the number and types of solutions. If I have a negative number under here, what kind of solutions am I going to get? Imaginary, exactly. How many? 2. You're always going to, imaginary solutions always come in pairs of 2 because they come for plus or minus the square rooting a negative number. Okay, so you can never just have one imaginary. So 2 complex is all you'd have to say. 2 complex roots. Because that number is negative, less than 0. All right, so then C just wants us to end up finding the exact solution. So we're just going to go ahead and finish solving this. So I got to do the opposite of B, which is 3. Plus or minus the square root of the discriminant. We already calculated that. All over 2A. Okay, 87 does not have any perfect square factors. So the only way I could break that up is the square root of 87 times the square root of negative 1, which is I. So square root of 87I. All over 6. Since this is a complex number, we do want to break it up. Real part first, which that would reduce to 1/2, 3 over 6. Don't forget plus or minus. Imaginary part second, I could only just write that as the square root of 87 over 6I. That's standard form of complex number. Okay, what if I would have gotten positive 87? What kind of solutions would I get? 2 real irrational, because 87 is not a perfect square. But yes, 2 real irrational roots. Okay, if you obviously get 0, like this one, that just means you're going to have 1 still real rational root. Okay, so you can kind of use that chart as a reference when you're practicing them, but I don't think we need to do another one of those. What do we got for time? I'm going to skip this problem. We'll come back to it if we have time. It's just another one with like decimals. Maybe just put this in your notes. So the tricky thing with this one is it says like give the answer in both exact form and decimal form. And if you were to go and do this like with the quadratic formula, you get decimals underneath your radical, which that's not going to give us an exact answer because I have decimals under a radical, and you're like, how can I do that? So does anyone have an idea of like what we could do to this equation before we plug the numbers into the quadratic equation? Idea?
Like 5 over 10.
Yeah, times everything by 10, right? Let's get rid of the decimals. Times everything by 10. So just write this part in your notes. Times everything by 10. That's going to give me 68x minus 20 equals 42x squared. And then you can go from there. I'll finish it if we have time, but I just want to do a couple other word problems. This would work if it wanted decimal form. Like we could square root decimals. Like we could figure out what this is. We just wouldn't be able to get the exact form from there. Okay. So we talked about this before, where this equation like comes from with factoring in like gravity, where that negative 16 kind of constant comes from, of objects that are like free falling, and how it's negative 16 if we're talking feet per second, but it was a different number, like negative 9.8. We're talking meters per second. All right, so basically we have that formula for us again, where the height of my object, this is h of t standing for the height, has this relationship, negative 16, that factors in the gravity of my t is your time. Do you guys remember what v sub 0 stands for?
Velocity.
Yep. Do you remember what the sub 0 means, though?
Initial.
Initial velocity, yep. That right there is my initial velocity. So obviously, like, velocity is speed with direction. Velocity is how fast something's traveling. If it's going upward, we represent that with positive velocity. If it's coming down, we just do negative velocity. Velocity is speed with direction. So h sub 0, since h is height, sub 0 just means the initial height. All right, so you're going to use this formula a lot. And the reason why I brought it back into the quadratic formula lesson is because a lot of these problems, we want to solve it with the quadratic formula because you get pretty nasty real life numbers. Okay, so here's an example. If Miss Hentrich throws a ball upward at 10 feet per second, okay, so that's a speed right there. That's my velocity, how fast the ball is traveling, 10 feet per second, from a height of 4 feet off the ground. Okay, so let's say I'm standing up on a desk or something like this, throw a ball up. How long will it take for the ball to hit the ground? So we're trying to figure out how long, so we don't know our time, right? This 10 feet per second, what would that be in this equation? The initial velocity, right? The initial velocity. Since I'm standing on a desk 4 feet off the ground, that's my initial height. All right, so let's kind of plug all that in. So we have, using that formula that factors in gravity and air resistance, negative 16, t squared is what I don't know. V sub 0 is 10, and that's a positive number because I'm throwing the ball upward. T plus my initial height of 4. Okay. Now I want to find the time in seconds of how long it will take for the ball to hit the ground. So that means if the ball's gonna hit the ground, that means I'm gonna have a height of what? 0, right? If not just on the ground, what's the height? 0 feet. So I want to figure out when my height, which is h of t, is 0. So we're just gonna plug 0 in right here. So this is a great example. I mean, these numbers aren't too bad, but if you were to try to factor this, it doesn't factor. So our go-to way to solve a lot of these word problems is by the quadratic formula, okay? And we want to do actually our answers as decimals with these. So let's go ahead and try it. We have t equals the opposite of v, which would be negative 10, plus or minus the square root of v squared minus 4AC all over 2A. Okay, I'll give you a second to write that down. I'm going to tell you right now what this all simplifies to. We get to here. Okay, I'm going to get my dot cam on so I can show you how to type this in your calculator while you guys write that down. Now, normally, we like exact answers, so we want to try to simplify that radical, except with word problems. Because if I asked you, all right, did you figure out how many seconds will it take before that ball hits the ground? You're like, oh, negative 10 plus or minus the square root of 356 all over negative 32 seconds. I'd be like, what? How long? Can you approximate that for me? Okay, so this is how we would type that in our calculator. You don't even have to worry about simplifying the radical when we're doing word problems. So we have two solutions here. We got to do, oh, that's kind of dark. Can you flip that light on? Yeah. No, the other one, sorry. My bad. There we go. That's better. Thank you. All right, so we have to do negative 10. Now, there's obviously no plus or minus button, so we have to do this in 2 rounds. Let's first do plus. Plus the square root of 356. Hit enter. Let your calculator calculate that. All of that's being divided by negative 32. So there's one possible solution of negative 0.2771. Okay, let's write that down. So one solution, negative 0.2771, yeah. That was from when I do the plus. I just do the plus first just because it comes on top. And you're like, negative time? That can't happen. All right, let's try the next one. Negative 10. And guys, you can do this. You can hit the up arrow and go back and just change it to a minus. You don't have to type it in again. All over negative 32. And you should get around 0.9. You can retype it if you want to, but I like to try to save time. Work smarter, not harder, am I right? All right, so for that one, we got 0.9021, ... This is all time measured in seconds, since my velocity was measured in feet per second. Now, if we're talking about time, which one of these doesn't make sense? Negative, right? So you can ignore that solution. The reason why we got a negative solution, though, really quick. So if I threw a ball, I'm 4 feet off the air, or 4 feet off the ground. There's me. Okay, I want some legs and arms. Well, yeah, okay, whatever. Here's me. And I threw this ball. We are essentially, since this is a parabola, figuring out the x-intercepts. So here's that 0.9 seconds. And then if we go back in time, we'd have another point where the height is 0, right? Does that kind of make sense? Yeah, but obviously that can't happen. All right. Follow-up question. What is the highest height the ball reaches? So if we were, again, to do like the trajectory of this ball. Now remember, I throw it upward in the air. So actually my last sketch I could have made a little bit more accurate. I didn't just drop it. I threw the ball up and then it came back down. So if I want to find the maximum height, thinking of this in the form of a parabola, what point would I need to calculate?
The one before it drops.
Well, I threw it up.
Yeah,
Vertex.
10. Yeah.
The vertex, right? The vertex would be the maximum height, or the highest point on this, the vertex. Do you guys remember how to calculate the vertex?
No.
Oh boy. Were you going to say something else, Carter? Sorry, you had your hand up. Or were you going to answer my question?
I don't know.
Okay. Let me know if you think of it. This little formula, x equals negative b over 2a. Remember that?
No.
Oh, well. Oh, jeez. Okay, well, good review. So my time is my x. The opposite of b is negative 10. It's almost like a little piece of the quadratic formula. Over 2a A is negative 16. This just gives me my time. I get 0.3125 seconds. So that's like the time after 0.3125 seconds. That's when it's the highest. Did they ask me what time, or did they ask me what is the height? Height. How could I find the height? Exactly. Plug that into our equation. Find h of 0.3125. This gives me the height, right? The height at any time t. That's what this notation means. The height at any time can be represented by this. So we just got to find h of 0.3125, which would be negative 16 t squared t squared plus 10t. I think I just need to go slower. Plus 4, plus that initial height. Okay, I would type it in exactly like this, parentheses and all, and I got 5.5625 feet. So that would be the max height at 0.3125 seconds. Okay. We're going to do one more, but it's very similar to the last one. So it's a good one to end on. Did you think of what you were going to say? Okay. This time I'm in a volleyball game. Not going. In a volleyball game, Miss Henchard spikes the ball over the net when the ball is 10 feet above the court. The spike drives the ball downward with an initial vertical velocity of negative 55 feet per second. There's the speed of the ball. That is coming in hot. Players on the opposing team must hit the ball back over the net before the ball touches the court. How much time do the opposing players have to hit the spiked ball? Okay, so again, we need to factor in gravity and air resistance using this formula. Negative 16 t squared plus v sub 0 times t plus h sub 0. Okay, we're still trying to solve for time. What is the initial velocity of this ball? Negative 55. Good. It's coming down, so we represent that with a negative velocity. Negative 55 feet per second times time. What's the initial height of the ball? 10 feet is when I hit it. All right, so how much time do the opposing players have to hit the spiked ball? So I'm trying to figure out when the height is what? 0 when the ball hits the ground, right? Because once it hits the ground, then the point's dead. Okay, then the ball is over. So you set this equal to 0. We don't need to go through the whole quadratic formula again. You can if you want to. Here's the time I got. So you'd use the quadratic formula. The hardest part is sometimes just like setting them up. Quadratic formula, you get the time to be about, so we got a negative 3.6106 ... 0.1731 ... seconds. We can ignore the negative time. So I only have not even 0.2 seconds. That's how hard I spiked that. All right, I do have worksheets to give you. Those of you that didn't ground yesterday. Don't leave until you get one. Actually, 2 worksheets.